Hi, for this recording, I will show you how to do 2009 MST question 5 part 5. Given the position vector of a point along the curve 3 cosine 2t plus 3 sine 2t plus 8t minus 4, and then what we're going to do is find the arc length now. Find the arc length of the curve from t equals 0 to t equals pi over 4. So in this case, this question had nothing to do with t equal pi over 4 now. So this ignore now. For this one, ignore, right? This is nothing to do with t equal pi over 4. We're going to find out the arc length from t equals 0 to t equal pi over 2 pi. So how do I do this? Let's recall the arc length formula. According to Howard Anton, if you have a graph in two-dimensional space or three-dimensional space given by RT, then the arc length L from t equal to A to t equal to 2b is given by this formula. Okay, so this dr dt is the velocity. Dr dt is actually the velocity. So we're going to find the length of velocity at any time and integrate that from A to B, t from A to B. So let's do it here. Our curve is given by 3 cosine 2t I, 3 sine 2t j by 8t minus 4k. The velocity we found out earlier, that is from earlier that with velocity by differentiation, that this is equal to minus 6 sine 2t plus 6 cosine 2t plus 8k. So what is the length of v now? The length of v will be equal to square root of minus 6 sine 2t square plus 6 cosine 2t square plus 8 square. Now let's simplify this. This is equal to square root of, you square minus 6 sine 2t get 36 sine square 2t plus 36 cosine square 2t plus 8 squared is 64. Now what is this equal to? Let's insert a new page. In this case, we know that sine square of an angle, theta by cosine square of an angle is equal to 1. So in this case, we have sine square of 2t. So I have 36 sine square of 2t plus 36 cosine square of 2t plus 64 with the square root. Using sine squared theta by cosine squared theta equal to 1. This is the length of v is equal to, using 36 sine squared 2t by 36 cosine squared 2t will give you 36. 36 versus 4 is 100. Square 100 is 10. So the arc length formula is equal to, integrate from the beginning is t equals 0 to 2 pi, the length of v dt. The length of v in this case we found out is 10. And integrate 10 and get 10t. T from 0 to 2 pi. So you put in the upper limit, which is 10 times 2 pi minus 10 times 0. So altogether you get 20 pi. So the arc length of the curve in this case is 20 pi. What is the key takeaway now? So the key takeaway, alright, so you have a curve moving on a three-dimensional space from t equal to a to t equal to b, and you're interested to find what is the length of this thing as it moves along the curve from t equal to a to t equal to b. Then the arc length L is integration from a to b, the length of velocity. Now the length of velocity could be integrate square root of dx dt, if your x component, differentiate of y component, dz dt square dt. That is the end of part 5 of question 5.